Good morning. Good morning, everyone. I hope you're enjoying the conference. Let's talk about API security, and more specifically about getting API security very wrong. That's not a part in the title, but that's going to be the line throughout the presentation. I'm going to show you how things go wrong in real-world systems, plenty of stories, and then we're going to talk about getting things right, some guidelines, some pointers, and some practical advice that you can use to look at your APIs and make sure they're secure or even make them more secure. And the starting point here is a study from about 2 years ago where a company looked at a bunch of e-health apps. And e-health apps, well, they handle sensitive data by nature. There's no such thing as non-sensitive e-health or healthcare information. So it's healthcare information, very sensitive data. And this study discovered like a bunch of problems. And one of these problems is that a lot of these apps, about 30 apps they tested, a lot of them, like 77%, contained hard-coded API keys and 7% had hard-coded usernames and passwords. That's not good. If you ever followed something about mobile security, lesson number 1 is typically like, hey, whenever you're doing something in a mobile app, in a front-end web app, you cannot put hard-coded secrets in there because it's very trivial to get them out. People can decompile the app and extract your secrets. If it's JavaScript, they can just look at the JavaScript, extract the secrets, or they can just monitor network traffic and investigate what you're including as a secret, get it out, and abuse it that way. So that's not really great. Same study looked at the APIs behind these systems as well. They looked at the APIs, and they discovered that a lot of these APIs, or all of the ones that they looked at, had authorization failures, BOLA attacks, broken object-level authorization. That brings me to the very first takeaway in this presentation already, so I have a whole bunch of takeaways in case you're wondering. The first one is that it's time to take security seriously. Or if you want to make it more exciting, the cowboy years are over, as in you can't really build an application anymore and be like, yeah, we'll worry about security later, because guess what? Later is never going to come. It's always like, oh yeah, we don't have time, now we have to build this feature and that feature. And by the time you're actually getting to security, it's probably too late, and it's going to be insanely difficult to get this done. So the real takeaway is that you have to ingrain security throughout your entire development lifecycle. From the start, from day one, you have to think about security, you have to build applications to enable security. Doesn't mean you have to do all the bells and whistles security first, but at least think about how things will evolve over time and set yourself up for success. That's essentially what this means right here. All right. Before we dive into the details, let me introduce myself. I'm Philippe De Ryck, and I'm a security expert. And I did a PhD in web security, so I've been doing security for quite a long time. And since a while now, I run my own company called Pragmatic Web Security. And through that company, I help developers build more secure applications. I teach workshops. I did a 2-day conference workshop right here in NDC London. I did one in Oslo last week. But I also do quite a bunch of in-house trainings where we actually dive deep into security topics with developers. Do some consulting, highly specialized consulting on complex topics, OAuth, OpenID Connect, API security. If you work with these topics, you know that there's a lot of stuff you probably don't know, and you need someone to help you explain that. All right, I'm also a Google developer expert and Auth0 ambassador, which is always a bit confusing. I'm not employed by these companies, but they like to recognize the work I'm doing for the community by having talks like this and sharing articles and resources and so on. And they recognize that, send me some free swag in return, and give me a nice title and badge I can put on slides. So thank you for that. Auth0 is here, by the way, at the conference. They have a booth downstairs. They have some cool swag that they are looking to get rid of, so if you want to talk about authentication, go visit that booth downstairs. All right. Finally, I organize a course in Belgium. It's a non-profit organization, SecAppDev. It's a course focused on secure application development. It's a week-long course in Belgium, so there's some benefits to being in Belgium. You can figure out what those are. But we also bring in experts from around the world to teach AppSec 1 week. So it runs in June this year, so look it up and make sure you can be there if you want to learn about AppSec. But enough about me, let's talk about security. Let's talk about the OWASP API Security Top 10. Very good resource about figuring out what's going wrong on APIs. If you know OWASP, it's a non-profit organization aiming to improve the state of web security, and they've been running this OWASP Top 10 for about 2 decades now. It's a very influential document to raise awareness about the 10 most dangerous issues in web applications. But APIs are slightly different, but not that much. So they also created, a couple of years ago, a specific top 10 for APIs with some major issues you have to investigate. By the way, the new version of this one is coming out in the coming weeks or months, so there's going to be an updated version. I haven't looked at the draft yet, so I don't know what's going to be in there, but I might have to update the slide when it drops. But I'm fairly confident that the top issues are not likely to change. Authorization failures, number 1. Number 5, it's all about authorization. And we're going to talk about quite a few of these things here in this session. All right. First thing to talk about is Bumble, a dating app. Bumble is a dating app using the traditional freemium model, so you can use Bumble and you get some free features, and after a while, if you swiped enough left and right, you have to pay them so they actually make some money, and so on and so on. And somebody looked at Bumble and investigated how they implemented these restrictions and limits, and it turns out that they did everything in the front end, in the mobile app. So you could use a mobile app and you were locked out or blocked from doing anything else, but if you knew how to send API requests, which a lot of you will be able to do, then you can still access the API as if your account was not locked or you didn't reach those limits. That's not good. In case you're wondering, that's not good. That's not what's supposed to happen. And this is a very, very common pattern that we see over and over again, like front-end apps, mobile apps, enforcing certain restrictions that are not enforced by the API. Enforcing things like transactional integrity. First we send request 1, then request 2, and then request 3. Think about a web shop. Fill your cart, pay for your stuff, ship it to your home. Well, if you can skip step 2, profit. Well, at least for you, not for the web shop. Very illegal, by the way, so don't do that. But these things happen quite often. Here's an example from Twitter where they forgot or they send a read notification from the front end, which you could suppress so you could read. This is about fleets, like a temporary feature that they quickly dropped after that. Never made it, but just to show you that these things occur quite often. And this is something I often see when talking to developers. There's very often security enforced in the front end without mimicking that behavior in the back end. And that is a problem. Because attackers, real attackers, they don't give a crap about your front end. They don't care about the mobile app. They will use a proxy sitting in the middle. They will use the app, intercept traffic, modify requests, and send them to the API in the back end. And they can do whatever they want. And if the API doesn't account for that, you are in a world of trouble. Seriously, this is not a good place to be in. So the client is irrelevant for security. What the client does is good for user experience and all of that stuff, but the real security is on the API, on the endpoints you expose. That's where you have to protect the application, not in the front end. Of course, the front end is not completely useless. So if you're also a mobile developer, don't worry, your job is not completely useless. Of course, we have that as a window to the API, but we can also enforce security restrictions in that mobile app, in that front-end app, as long as we do the same thing on the API. And then things get interesting. Because if you enforce authorization or input validation or whatever, both in the front end and on the API, guess how often that should fail on the API? Never. It's there to protect you, but it shouldn't be triggered. And that means if it triggers, if your API decides like, hey, this user is not allowed to access admin features, why is this here in the first place? How did they get here? Either you have a bug, that would be my case, I probably screwed up the front end, but since you're good developers, your front end is going to be solid, so somebody's attacking your API. So now you have a high confidence signal that somebody is tampering with the application, sending you stuff that is never supposed to reach you, and you can use that to monitor the behavior of attackers. You can use that if you're building sensitive applications, you can use that as a high confidence signal in your security monitoring, like something is really wrong, let's look at what this user is doing. Let's keep track of that, or even, if you want to take evasive action, let's block that user, divert them to a system with no sensitive data, whatever you want to do to actually fix that. So the real takeaway is that the client is irrelevant to enforce security. Enforcement is an API thing, not a client thing, but the client can, of course, aid in the whole process by ensuring that the same controls are also enforced on the client. All right. Back to our stories. Grindr had a security problem. Like so many applications, Grindr has user accounts. You can sign up with your email address and so on and so on. So like so many applications, they have a password reset feature because, well, we suck at keeping track of passwords. And you know how a password reset feature works, right? You enter an email address, so you go to Grindr, you enter philippe@pragmaticwebsecurity.com, and you submit that, and I'll get a mail in my mailbox with a unique link. And that link is like reset password with a unique token that allows the user with that link to reset the account, the password from my account one time. If you fill that out, you can't read my mailbox, hopefully. Otherwise, I'm in big trouble. But you can't read my mailbox, so no attack factor there. And the front-end application, if you enter an email address, the front-end said like, yeah, we send an email to that email address, go check your mail. No attack vector there. However, if you would inspect the actual network traffic, you could see the request go to the API, and the response comes back, and it's like status, success, secret password reset code, something, something. In the response, in the JSON data. The front-end never shows it, but the API exposes it by accident. That's a mistake. That was not supposed to be there. If you can look it up, figure out how you use the network tools, like it's not a very sophisticated attack. You inspect the network traffic in your browser, look at the response, like a second tab, and you can get the data, and off you go. And with that token, of course, you can reset the password from my account, and we again have a security vulnerability. And this problem is in the OWASP API security top 10 in spot number 3. If you paid attention, you knew what that was. If you didn't, I'm going to tell you, so don't worry about that. It's called excessive data exposure. Because the API is returning data to the front end that the front end never uses, and in this case, creates a significant vulnerability. And this is a really common problem. Here's an example for the API security swag shop, whatever. It shows a list of online users. Not sure if that's like really privacy sensitive, okay, but whatever. It shows a list of online users. So there's an API call to the backend to get me a list of online users, and it returns a set of JSON information, and we can easily render that as an array in the, it's not very sophisticated UI design, I know. But straightforward, right? However, in the backend, to get that list of users, we have some users somewhere. Users have properties like addresses, and that information is just sent back in the response. This is extremely common. You want to know how common? Open up your DevTools and go to any application you use day in, day out. Open up your online bank and look at what traffic they're sending back and forth. It's absolutely insane. There's a lot of information there. Happens quite often. Why does this happen? How do we get here? Well, in this particular case, it's because we're using a data class somewhere in our system. It's Java, my apologies for that, but the benefit of Java, everybody can read it. Never saw Java in your life? I mean, it's so verbose, it just basically tells you what's going on. So in this case, we have a list of online users, we get that users, we have a list of actual user objects, and users, of course, have an ID, a name, an address, and so on, and we just throw that in a response. Like, here's the list, bam, response, whoop, out goes the JSON. We don't construct JSON by hand, it just happens automatically, because otherwise our lives would be living hell. If you've ever done JSON by hand, you know exactly what I mean. Not fun. So this is how this happens, right? Return the users, and off we go. Data marshalling from objects to JSON very often leads to exposing sensitive data. How can we fix that? Well, there's a crappy solution and a good solution. The crappy solution, well, it's not that crappy, but it doesn't really work at scale. The crappy solution is to use annotations. You can say, like, hey, JSON parser, let's just pretend the field is not here so we don't accidentally expose this. JSON ignore. It works, but I'm not a big fan of that because you can imagine it works for like this super simple example on PowerPoint, but a real-world application with like dozens of these data classes going through all the fields and adding annotations left and right, that's not going to work very well. And if you miss one, you have a vulnerability. Whoops, password reset token, okay, yeah, we missed that annotation, our bad, and you have a problem. So a better approach is to use this age-old pattern called data transfer objects, or a schema, or whatever works in your language, because this translates to different languages in different ways. But instead of returning users directly, we're now returning a public user info object, making things very clear about what's going on. What are we returning? Public user info. What is public? Oh, an ID and a name. Like, yeah, that makes sense. If you ever need to add a new field, well, if you add a field like credit card number to public user info, that's on you. That's not just a simple mistake you make. That's like, I don't know, Monday morning code after a heavy weekend of spending in the pub, something like that. But this makes it very clear, allows you to review your DTOs and be like, yeah, that makes sense, and this actually explains what's going on. All right, automatic marshalling from objects to JSON results in excessive data exposure, number 3 in the top 10. What if we flip it around? What if we marshal JSON back into objects? Can we then trick the API into accepting data? And after building this anticipation, the answer is not no. Yes, we can. Otherwise, it's going to be pretty like, oh, no, we can't. Haha, gotcha. Next one. So this is called mass assignment. It's the same problem, but the other way around. Mass assignment means that the user is giving us data, we're transforming that data into an object to work with because we don't want to deal with JSON as a raw value, and that object makes its way through the application to the data layer and results in updates in the database. And this is supposed to be like that. There's a user class on the left, again, Java. We have a request on the right to update my name. My name becomes Dr. Phil, which I can actually do, so that's pretty cool. So, well, I'm not sure if that's cool, but sure, if you're old enough, you know what I'm talking about. I can send that request and update my name. That's a legitimate scenario, and everything goes well. You have a unit test that checks this, and all is good. But look at the class on the left. Let me see. Yes, my highlighter works. Class on the left has a role parameter. Guess what that does? That's used for authorization purposes. I may be a user in the system, so my role is user, and that's it. So what if I send a request with like additional JSON properties? What's going to happen here? In this case, my name is Philippe becomes admin, and my role is admin, and I send this, and the system's like, yeah, I'm going to translate that into a user object, give it to the data layer. The data layer is like, which fields have changed? Oh, the name, update the name. Oh, the role, update the role. Bam. Philippe is now admin. Mass assignment. Real-world vulnerability leads to massive problems, account takeovers, changing prices of products in web shops, all kinds of nasty consequences. How do we fix this? Annotations. We can do like access read-only. It works. Like if you have one field, this is probably fine. But if you do this at scale in a real-world applications, this is not going to work very well. So you use data transfer objects or schemas or whatever works in your language. You basically restrict what information is acceptable, only as a fixed set of fields, and now you have a very clear idea of what you're accepting, and you can translate that to what it means and update the system correctly. All right. The takeaway here is to test your APIs in their natural habitat, as in you have to test these things out. This is not something that screams at you from code analysis like, oh my God, this is wrong. This is a very subtle problem, and doing code analysis doesn't always reveal it, especially mass assignment. So you have to try this out. You have to test this, write a test case, mess around, tamper with your own requests and responses to see what's going on and if you can make the API misbehave. All right. That brings us to another question. I have a lot of questions in this presentation, even though there's no interactivity. So just do it in your head. That might work. And the question here is this really a good approach? Like, yeah, you can test your APIs, and maybe you can hire a pen testing firm to test your APIs, and they'll tell you like, oh, whoops, excessive data here, mass assignment there, left, right, and so on. And then what? You can fix them. That's step one, probably. And then you keep developing your API, so when are you going to test again? Tomorrow? Well, probably not. Especially if you get the bill from a pen testing firm, that's not going to be for tomorrow. Maybe next week, next month. Well, yeah, let's do it like twice a year. So in these 6 months, you have nothing. That's called fingers crossed security. Doesn't really work very well. It's like, yeah, things might work out, but maybe they don't. So testing is useful. Testing is good. Yes, you can test this, but it's not a scalable approach that will allow you to apply this in the real world. Something that might work better is using API contracts. If you specify an open API contract for an API endpoint, you are defining the exact behavior that you want to see. I'm going to apologize again. It's YAML. I know. My apologies. But there's tool support to help save your spacebar, so you don't have to be like ramming your spacebar the whole time. Tools will actually help you write these schemas. But this is really, really useful because it defines the behavior of the API. It defines, in this case, the exact response of that list of online users. And guess what's not there? Address. This is an ID and a name. That's all we really care about. And that's what we want to see in the response. Very clearly defined. How do you use these things? Well, you write them. You can review them. That's good. But the evolution that we're going towards is having tools that use this as input so that they understand your API. Tools like Fuzz Lightyear, which you can use for fuzzing your API. It will send you a whole bunch of requests and try to make your API fail on certain inputs. Or Microsoft has a tool called Wrestler that might do something that does something very similar. That's one suite of tools, like testing tools that understand where the inputs go, the format of the inputs, and hey, if we give you a string where you expect an integer, do you actually fail? Proper input validation, proper checks, and so on. And the second phase here, the second step, what we're going towards, is actual enforcement at runtime. you have API gateways, API firewalls that will actually be able to take a schema as input and actually enforce that on incoming requests, like API Shield from Cloudflare. It's an enterprise feature, so I haven't tried it because I don't have an enterprise plan. But if somebody from Cloudflare is here, just give me one and I'll try it out for you. That might be awesome. But Cloudflare does this. 42Crunch is a company specifically dedicated to this space. They have an API firewall that does this on requests and responses, automatically based on the contract. That's the takeaway here. Write the contract, write your API to the best of your abilities, and now you can map these things together and make sure that the API behaves as you defined in the contract. And if you accidentally expose the password reset token, the contract is not going to contain it, so you have a mismatch and you can detect that or even fix it at runtime. All right. Let me take a moment here and ask you a question. Who here is using API contracts? A handful of people. All right. Interesting. Who here is using them for security and not just for documentation? Crickets. Nobody. If you're watching a recording, like literally nobody. Everybody's like, crap. All right, a couple of takeaways. For the people not doing API contracts, start doing that. Why? I'm not saying write like 15 pages of contracts for all your APIs, but learn how to deal with API contracts in the real world. This is not an easy thing. It seems like, yeah, let's write some YAML and we're done. No, it isn't. The hard part's keeping this thing in sync with your actual implementation. Because it's not like you write it once, you drop it somewhere, and then you just code your API, because guess what? If something changes, you have to update the contract. Learn how to keep these things up to date. Learn how to deal where to best put the contracts. What works really well is like having code in the endpoint implementation, so you can actually having comments in your code, so you can keep these API contracts close to where they are, keep them up to date, and so on. Learn how to construct documentation from that and deal with that in practice. One of the things you should not do, well, at least for security, documentation purposes, that's different, but for security, you do not want to auto-generate your contracts from your code. Yes, there's tools that do that, and no, they're not very useful in this case. Because guess what? If you have excessive data exposure or mass assignment in your code, and you auto-generate a contract, you'll have the same vulnerabilities in the contract. So you gain nothing, basically. These tools are built with documentation purposes, like create documentation from the implementation, which is also I'm a bit skeptical about that, but that's not how security works in practice. Seriously, this might be the most important takeaway from the entire presentation. Look into using OpenAPI contracts. All right. Got this? Really important. Let's talk about authorization. Let's talk about T-Mobile. They've been in the news recently because they had another breach, like whatever. I've been using this slide for a long time because it's from 2017, but it highlights the point very aptly, and well, let's say that T-Mobile has had some issues since then that they might have to deal with. But the problem here is that with T-Mobile, they had an authorization failure. And how does that work? If I'm a T-Mobile customer, I can get my account information by contacting an API endpoint. And the ID of my account is my phone number. Kind of makes sense. It's a unique number anyway, so let's use that as an ID. Sure, why not? If I send a request, they check if I'm authenticated. Good. And they get the account information, and they send me back the response. But if I want to get your account information, I send a request to the API, substitute my phone number with your phone number, send it. T-Mobile is like, are you authenticated? Like, oh yeah, you are. Here's the account information. Whoops. They forgot about authorization. And this vulnerability used to be called IDOR, Insecure Direct Object References. That's kind of the old crappy name. The better name is Broken Object Level Authorization. And this problem is everywhere. Remember that story from the beginning, slide number 2? Every single API of those healthcare apps had BOLA vulnerabilities, this problem. And in India, a while ago, they built a patient portal, whoops, Broken Object Level Authorization, you could access other patients' information. And with Twitter, they had a problem where you could map phone numbers to Twitter accounts. And on Facebook, they had a problem where you could take control, well, change the name of a Facebook page and then register a new one with the old name, so everybody would come to your page instead of the legitimate page. pays out 15,000 USD in bug bounty, so this is not a small, insignificant vulnerability. This is a real problem that Facebook paid real money for reporting that. Broken object level authorization. How do we get there? What is it and how do we get there? Well, the starting point of getting there is this: building a RESTful API in 10 minutes. I can tell you that in 10 minutes, there's not going to be any security in that API, which is okay. I'm not bashing the tutorial here. This is a fine tutorial to learn about RESTful principles in Node.js. And it explains to you how to build take a wild guess what application we're going to build? A to-do application, yes. Tasks, because everybody has tasks, like always tasks. By the way, in my trainings, I use restaurant reviews because I like good food and I hate tasks, so it kind of works out well for me. That said, if you want to build a RESTful API to delete a task, you send a delete request to the application, like the HTTP method delete, you handle that, you get a task ID, you find that task, you drop it from the database, and you're done. That's what you learn in a tutorial like that, and that's exactly how REST APIs work. And if you've done that, you're like, okay, I got that, awesome. Let's add security. You're going to add authentication. That's going to be the next step. You'll follow a tutorial somewhere on the internet that's going to be like building authentication in Node.js in 10 minutes, and you can follow that one, and you will get somewhere that says requires auth. Good. If you're T-Mobile, at this point you're like, job done, bye-bye, next. You can cross off the task. If you're someone else, you might want to think a bit further, like authenticating the user is good, but how do I know that they can delete tasks? Maybe we need to add some authorization. So we check, has permission delete task? That makes perfect sense, right? Because maybe only Philippe is allowed to delete tasks, but not the other user. At this point, we have implemented function level authorization. We already fixed one of the OWASP API Security Top 10 issues, number 5, is now fixed. Function level authorization, good, awesome, good job. T-Mobile, you. That's I'm going to get in trouble for this, but we'll deal with that later. What we haven't fixed is object level authorization. How do we know if you're allowed to delete tasks? How do we know you're deleting the right tasks? What if you want to delete my tasks? Are you allowed to do that? Well, that requires you to look at the actual task and the user and the permissions and so on to deal with that. And that is broken object level authorization, and that problem exists in a lot of APIs. But we'll talk about that in a second. First, the takeaway here is enforce authorization at the function level. That's a good thing. That's something you have to do. And to be honest, that's something that a lot of APIs actually get right as well. It's not too common to see completely no authorization at all. It happens, but not that often. That's good. Let's take a sidetrack here before we talk about object level authorization. Let's look at authorization in general. Here's 2 requests. On top, you have one for getting tasks, and at the bottom, you have one for deleting tasks. All right? The top one has no authorization logic here. The bottom one has a permission check for deleting tasks, function level authorization. Good. Is this correct or not? I don't know. I'm often in this position where I'm working with a team on improving their security, and we look at authorization logic, and I'm like, is this correct? And I have to ask, like, do you actually intend that getting task is publicly accessible? Like, can everybody see a list of tasks? Maybe it's like the super accountable task manager where everybody can see the stuff you have to do. That might be, I don't know. Or maybe somebody forgot authorization. The fact that we can't see this, the fact that you have to look at this snippet of code and be like, yeah, I don't know if that's supposed to be like that or not, that means this policy is not easy to audit. It doesn't scream at you that this is either a mistake or publicly accessible. It's like, oh yeah, this is a subtle detail. Something is missing, and because of that, everybody can access this endpoint. What if we make everybody's life easier by doing like just a little bit more effort? We can do something like this. Allow public access. Guess what? If this was not supposed to be the case, and you look at your API code now, or you bring me in to help you with that, I'm going to be like, why the hell is that endpoint public? You'll be like, oh yeah, whoops. I don't know. But it's not going to happen because you'll see that. You'll see that immediately if you look at the code that something is really wrong here, or you see that this is actually intentional instead of just an oversight. And this takeaway is so important. Empower auditability. Because the security of your authorization policy is completely dependent on your power of auditing the policy. Because if you can't review it, how the hell do you know that it does what it's supposed to do? Again, we're back to fingers crossed. It's like, yeah, it's probably good. Very likely it isn't. All of the healthcare APIs had BOLA vulnerabilities. I don't know the details, but I'm fairly certain that a lot of those policies were impossible to audit. Really, really important. All right, let's go back to broken object level authorization. Why is that issue so common? Because it's a nightmare to actually enforce. Here's an example of what you'll end up with. And I'm not joking, I see this code in different contexts. Of course, I don't review to-do applications, but in different contexts, I see code like this all the time. The clue is on line number 4. Like, yeah, we check functional level access control, delete tasks, the user has this permission, and then it's like, oh, if you're an admin or a manager, like, yeah, you're allowed to do that. But if you're not, if you're like a regular employee or a regular user, you can only delete your own tasks. So now the fun starts like, oh, if the user is this, then we have to check that. And again, auditability of this is an absolute nightmare. How do I know that you covered all cases? I don't. It takes very intricate knowledge about the business domain to assess whether this endpoint is implemented securely. And I don't really like that. So how can we improve this? How can we fix this? Well, first step, or an important step, is pulling that authorization logic out of the application. So instead of doing everything in the API, what if we put our authorization logic separately? And you're developers, you're engineers. I can already see you overthinking this. I can see you thinking like, oh yeah, we can probably find a service that handles... No. The simplest version of doing this is using one code file. You copy the logic, you move it into an authorization policy JavaScript module or Java class with static methods or whatever you're doing, and you ask, can delete task. Very simple, very straightforward. Very under-engineered, by the way, by design. Because everybody can do this. It costs you zero money for vendors. It doesn't require you to spin up a separate service, to run a separate product, to find something that suits you. All it takes is writing a few lines of code, and that's it. And this gives you massive benefits. First of all, if I have to review something like this, I can say very fast, like, yeah, this makes perfect sense. Deleting tasks, you check the authorization policy, good. I'm not saying that your authorization policy is correct. I'm saying the endpoint code is rock solid. Awesome. Second step in this would be evaluating the authorization policy. Does this thing do what you want it to do according to your business rules? And it's now centralized, so you have one file you have to review. Awesome. You have one file you can unit test. You can unit test your actual policy without having to deal with endpoints and requests and responses. You can just write a set of unit tests. You can apply source code control on that file. Like somebody, you can log the file and nobody is allowed to update the authorization policy by accident. I've seen it as well. PRs, like a pull request where somebody's like, yeah, I'm going to change something here and delete this part of authorization logic because I don't think it's necessary, and bam, vulnerability. This will help fix that. So this makes your code a lot better. Well, at least line 4 makes your code better. Not just the sad face as exception handling. That's not a very good way to handle errors on line 7, so don't do that. But take the relevant parts here, line number 4. And yes, let's bring you back to the engineering part. Yes, you can make this better. You can implement some centralized services. You can implement things like a policy engine where you use a service to handle your authorization logic. But that's for complex use cases. If you have like a really advanced policy, writing that in code is not going to work very well anymore. So you can use tools like Open Policy Agent, like an OSO, like so many startups are building now. This is a hot topic in startup world, fixing authorization. This will be possible. But the first step is centralizing it yourself, and then if you're like, yeah, this thing is becoming too big to really manage, let's push it out to a separate service, that is perfectly possible as well. Key takeaway here is centralization. Either in code or as a service, whatever floats your boat. You can have various degrees of complexity here, but this is a better way than having it scattered throughout the code. Because it allows you to audit the policy, it allows you to test the policy, to control who changes it, and it will make things better in the long run. Trust me on that one. All right. What else do we have? Well, I make it sound like there's a choice, but there really isn't. It's like a sequential set of slides. So How do we make authorization decisions? Well, we talked about the specifics, but we have to get the user information from somewhere, right? The user typically authenticates to an authentication service somewhere or an authentication endpoint once. We don't authenticate every time. We don't provide the user details on the user's authentication details on every request. We do it once, and then we propagate authentication state. Some people are old enough to remember the concept of session management, like, whoa, 30 sessions. Well, 30 sessions is one way of doing that. You can have a J session ID. It points to a Java session, server-side object, keeping track of information for this specific session, this specific user. And we can keep track of the user's authentication state and their roles and their permissions and whatever we want to keep track of. And this mechanism is beautiful. I'm not joking here. This is actually beautiful. This is a secure server-side environment. Nobody can really go into the server and modify values in memory or in your cache or whatever you're keeping that. This is a solid place to store that data. Yes, it has some drawbacks. No, it is absolutely not an invalid pattern for APIs. You can use that in modern applications. In fact, this pattern is well supported in many platforms. Heroku, where you can deploy cloud-based applications, has built-in session support for Java using a Redis cache. Is it completely stateless like the major applications are doing, like you build Facebook or Netflix? No, it isn't. Does it work well for an application with a few hundred or a few thousand users? Yes, it does, beautifully. And it will make your life extremely easy. Because you don't have to worry about pushing data to the client, about whether you can trust that data when it comes back and how you secure it, how you revoke an active session, how you log a user out, and all of that stuff, magically solved by server-side sessions. Yes, they're ugly in some respects. Yes, they are not infinitely scalable, but for many applications, this perfectly suffices. I can't tell you how often I have the case where a customer is building a new app. And they're like, yeah, we want to make this stateless and use JOTs that we push to the client and this and that, but we have these and these challenges. Like, yeah, of course you do. And my question is, how many users do you have? Like, yeah, we have, in this case, it was a very specific application for their customers. We have like 50 to 100 users. It's like, what the hell are you doing? Run that with a server-side session on a single server, and it's going to work beautifully. And you want load balancing, then have two. With session replication, it's going to work beautifully, saves you a whole bunch of headaches, and this actually saved them a couple of days of time in building that simple application, just by using proven concepts. And the takeaway here is that traditional web sessions, people will tell you that APIs can never use cookies, and they're wrong. As proven by half of the internet, actually. Traditional web sessions are still valid. They make your life extremely easy, and sometimes you don't need to push it to the extremes. But sometimes you do. And when you do, there's a whole bunch of approaches you can use. There's some custom token mechanisms. There's a very wrong way of doing it, the more better way of doing it, and then there's the state-of-the-art or the best practice of doing it using OAuth. Using OAuth is not going to make your life easier. It's going to make your life harder, significantly harder, to be honest. Starts with figuring out which spec you need to read, because there's like a dozen that overlap and deprecate stuff and add new stuff, and trust me, I've been there for a long time. This is not an easy approach, but it has benefits. Because in OAuth, I'm just going to give you a quick rundown of how it works. I'm not going to dive into detail. We don't have that much time here. But in OAuth, clients and users authenticate to an authorization server. Not the authentication server, but the authorization OAuth stuff. Anyway, centralized handling of credentials and client authentication and so on. And then afterwards, they contact APIs with access tokens. And that access token represents the authority of the client to act on behalf of the user or as a client directly to the API and allows the client to handle, or the API to handle authorization. Awesome. If you're an API developer, now you're happy, right? Tokens. Oh, thank God, that stuff about sessions, what the hell was that about? Tokens. Now everybody's happy. Good. Did you know that OAuth has two types of tokens? You have, somebody's nodding yes, good. You have reference tokens and you have self-contained tokens. Here's how a reference token works. So a reference token is called an access token, but it's basically just like a random ID. It doesn't contain anything, and it points to state kept by the authorization server, server-side state. So even in OAuth, you have tokens that represent a session ID. We just call them an access token because we don't want to call them a session ID, but they represent the same thing as a session ID. When the API receives that, they will have to do token introspection, process where you go back to the authorization server, ask like, hey, I got this ID, what does that mean? Oh yeah, here's a bunch of claims, thank you, and now you can make authorization decisions. That's one mode of operation. Very, very similar to server-side session management with the same security benefits and the same drawbacks. Just so you know, even with modern state-of-the-art approaches, we still have server-side state because it's a valid concept. Of course, all the cool kids are doing JSON Web Tokens. So you can also have access tokens in the format of a JSON Web Token, where the client gets a JOT, the JOT contains all the claims, you send that JOT to the API, and the API can verify the signature, get the claims out, and use those claims to make authorization decisions. Obviously, better scalability properties, because now there's no direct link to the API and the authorization server, there's no heavy communication there, and APIs can validate tokens independently. But this approach has some revocation issues. They should be short-lived, so because you can't really terminate tokens proactively and so on. Just so you know that these things exist. The takeaway here is basically that you want to analyze your security requirements carefully. Because sometimes you don't need to go full overboard with things like OAuth, and sometimes you don't want to use JSON Web Tokens but want to use reference tokens. And sometimes you'll have to decide, and the trade-off is going to be not that clear, and you'll have to accept certain risks in favor or in exchange for certain benefits, or not, and the other way around. That's a very important takeaway. We've been talking about JSON Web Tokens now, so I have to say a couple of things about that. JSON Web Tokens are a mess. There's a whole bunch of security pitfalls and vulnerabilities and things to take care of, and I don't have the time to talk about them. So what I'm going to do is I'm going to give you two references. One is a spec. I know everybody loves reading RFCs, so that's good news because this is an RFC. Number 8725, if you want to know. But it's a very consumable RFC. It's about JSON Web Tokens and it has two meaningful sections. There's like the introduction, which is whatever. Section 1, problems with JOTs. Like just a list with some explanation. Section 2, fixing JOTs. Like recommendations with explanations. That's it. There's no weird ASCII diagrams and stuff like that. It's just like, hey, here's some problems, here's some best practices, follow them. Thank you. If you like to read prettier content, I've also written an article about JSON Web Token security pitfalls a year and 2 months ago. So that might be a bit more consumable than RFC. We have some nice pictures and so on and so on. I don't care what you read. This is just some pointers, but read up on JOT security. Make sure you avoid these common pitfalls. All right. Follow JOT security best practices. That brings us close to lunch, I know. People are anxious, like, oh, come on, I'm hungry. Are we done yet? Almost. I have another question to ask. Yes, another one. What happens when poo goes wrong? I'm being recorded here, so I have to be careful. What happens when something goes wrong? Far too often, when something trivial goes wrong, everything breaks. When something trivial goes wrong here, it means like a full system compromise, and that makes no sense at all. Why on earth are we running like super unsecure features alongside the main application? Alongside super trusted features like user authentication and stuff like that. Like, what the hell are we doing? Compartmentalize your APIs. Very easy to say in PowerPoint, like, yeah, just split them up, like untrusted stuff here and have some boundaries, and then the main application APIs, like, and then some boundaries, and then the highly sensitive services. That's the awesomeness of my job. I just have to draw some lines on a slide and I'm like, done. You do that. I know this is not easy to do in practice. I know this is not trivial, and that's why we often don't do it. But this is your only fighting chance to stop an attack from fully compromising your backend services. This is what we need to do to try and contain the outfall of an attack, because some vulnerabilities are going to exist and somebody's going to exploit them at some time. And if it happens in this super unimportant search feature in your application, you want to be able to tell your customers, like, yeah, we had a problem. Well, best case is we had a problem, nothing was compromised, so we don't even have to report it. That's good. And otherwise, it's like, yeah, we had a problem, but guess what? None of your data was compromised. Did you ever get an email like that? No, of course not. But this can help you getting there. Compartmentalization is really important to reduce the impact of a vulnerability. And yes, it's a pain, And no, it's not something you just decide in 5 minutes and do it, but it's something you have to work towards in practice. And in that light, I have one more topic to talk about, and that is using web application firewalls or API firewalls or API gateways and so on. We've been using these devices for a long time as like a first line of defense. I always run into them when I do cross-site scripting in my workshop because people are on their corporate networks and they do XSS attacks on the demo or the training application, and the firewall is like, you can't do cross-site scripting. Then I tell them, like, here's how you get around that, which is somewhat questionable, but no offense, the WAF that they're using is probably pretty stupid, so it doesn't really account for much. But there's a change here. There's a change in API-based systems that we're trying, or not trying, we're moving towards using these devices as actual defenses. You can find API gateways that do things like rate limiting, or authentication, or API gateways that will do enforcement of contracts on requests and responses. And that means that they're no longer a first line of defense, but they're the defense. For some things, the only line of defense. And that's, by itself, not a bad pattern. That's good. We can do that. That's what these products are for. But it also means one very important thing. You have to make sure the attacker can't get around that WAF, that gateway, that firewall. I have a good image to illustrate that. You're not supposed to implement an API gateway like that. That's not very good. Might work in the UK because it's going to be mud and nobody can get through it, but in the rest of the world it doesn't rain that often, so it should be fairly accessible. But seriously, this is a real problem in modern systems. We call those APIs, let me skip back here, we call these applications, these APIs, the origin servers, the actual service handling requests, and they're not supposed to be exposed to the internet. You have to make sure that there's no path around that gateway to access the origin server directly. And this is something that comes up quite often in vulnerability reports or in penetration testing reports and so on. Because once the attacker figures out where the origin server is, they can access it directly. Guess what? No rate limits. So all of these brute forcing things that you thought were covered are no longer covered. Like MFA codes, like 4 digits or 6 digits, well, brute forcing that is not that hard. Bam, whoops. All of these things going wrong. So the takeaway here is make sure that if you rely on perimeter level security for the actual security of your applications, that it's not bypassable, that there's no path around it. Try to hide origin servers, which is not easy, by the way. So assume that the attacker will always discover where the actual origin server is and make sure they can't access it. And if they can access it, move the defense closer to the API. If that's your deployment model where you're like, yeah, we can't prevent this from happening, then guess what? You can't do perimeter security because you have to do it closer to the API. That's the final takeaway here. So now it's up to you. My part is done. I told you what to do. So now you enjoy the rest of the conference first, and on Monday you pick one of these topics and you do them. That's how you improve security. It's not like oh yeah, that was interesting, and then do nothing and the same thing all over again. No, you take one of these things. My recommendation, look at your authorization policy. Open up your API, look at your endpoints, and see, do I actually understand what's going on here? Can I tell if this is a secure policy? If the answer is no, well, maybe try again on Tuesday, because I don't know what happens on Monday in your world. But if you can't tell this, improve it. Your policy is not auditable enough. Refactor it to make sure it becomes more clear. Apply what we talked about here. Write security tests to verify your authorization, improve your JOT handling, build open API specifications. There's so many takeaways. Use that information later on to review your systems. All right, if you go to my website, you'll find the slides there as well. If you want to learn more, hire me for a security workshop. I can go into plenty of detail on each of these topics if you want to. I have some online courses as well on my website, so you can look at that. And with that, I basically want to say thank you for being here. Thank you for listening. Thank you for staying, which usually is not a problem, so that's good. I hope you enjoyed it, and we have a few minutes for questions if you're not too hungry. There's a mic up front, so you can come up front, ask your questions, so it's also on the live stream. And then afterwards, we can enjoy lunch. Thank you. Are there any questions? Yes.
Yeah, in a few words, what's the option if we can't hard-code API keys in the client? How do we make sure that the client has access to it?
Yeah, it depends on the client, what that means. If your client runs on a user device, then no, you can't hard-code it because they will get it out anyway. If your client runs in a secure environment, such as a server-side application, you can provide that through environment variables or whatever config. So that's server-side environments, easy to handle. User devices, not that easy. Very often, clients running on user devices, they only need access on behalf of a user. You don't really care which client it is, you care which user it is. So in that case, the user would follow an authentication step, and the client would get some form of token representing that authentication and can use that one to authenticate calls to the API. If you can do that, then the whole problem goes away because you don't really need to authenticate a specific client, just the user using the client. And then for client-specific authentication, if you really want to do that on user devices, it involves generating a secret on the device and then having a registration step where you share it with the API. So for example, a mobile app could generate a key pair and then register itself with the API through a registration endpoint, which is unprotected, but that's how it is. Like, hey, I'm this client, here's my public key, and whenever I sign something with my private key, you know it's me. And then you can associate identity with that, and you can use that for authentication. That registration step in a corporate setup, that typically is something where you have to register your device once with like a code you get from somewhere, you copy-pasted something. Stuff like that could work as well, scanning QR codes. But that's how you do it. You generate secrets on the device and use a registration step to link the client to that secret on the API, and from that point on, you have your authentication. Awesome. That was a good question. Thank you for that. Anybody else? Well, you can always grab me during lunch because I'm also hungry, so I'll see you downstairs. Enjoy the conference.